Welcome back to my channel Electronic Science Tutorial. Today is the fourth class of an operational amplifier or op-amp. Today I will discuss the common mode operation of an op-amp and the common mode rejection ratio. So without any time waste, let's start our class. So what is the common mode operation? This is the circuit diagram of common mode operation of an op-amp. This is the non-inverting terminal and this is the inverting terminal. These two terminal commonly connected by a input signal voltage, and the result of the op-amp we get from the output voltage. So this is the common mode operation circuit diagram. When the same input signals are applied to both inputs, common mode operation results. Ideally, the two inputs are equally amplified, and since they result in opposite polarity signals at the output, these signals are cancelled out and resulting we get a zero voltage output. But practically a small output signal will result. If we think that here we apply positive 5 voltage, that means positive 5 voltage is applied into the non-inverting terminal and the inverting terminal also. From non-inverting terminal we get positive output, that means plus 5 volt, but from inverting input we get minus 5 volt. So plus 5 volt and minus 5 volt cancel out each other and we get the zero voltage output from the output voltage. That means ideally the two inputs are equally amplified, and since they results in opposite polarity signals at the output, these signals are cancel out and we get zero voltage output. But practically this is not possible. A small amount of signal voltage we will get from the output voltage. Okay, so this is the operation of common mode. Next we talk about the common mode rejection ratio. What is common mode rejection ratio? An op-amp is basically a differential amplifier with signal voltage which is applied at the non-inverting terminal and which is applied at the inverting terminal. Each voltage is measured with respect to the ground. First, we apply V1 voltage at the non-inverting terminal and V2 voltage at the inverting terminal. V1 voltage is applied to the non-inverting terminal, that means positive terminal, and V2 voltage is applied at the inverting terminal, that means negative terminal. Okay, so what is the difference of the signal? The output voltage appearing from the V0 and which is called as the difference of the two signal that is to be applied at the inverting terminal and the non-inverting terminal. So what is the difference of the two signal? That is represented by Vd. Vd equal to V1 minus V2. This is the equation 1. And also the average of the signal which is to be applied to the non-inverting terminal and the inverting terminal, and that is measured by Vc, which is called as Vc. Average voltage means how we can represent this, that is V1 plus V2 by 2. This is the equation 2. V1 voltage is applied at the non-inverting terminal and V2 voltage is applied at the inverting terminal. So the difference signal is Vd, that is equal to V1 minus V2, and the common mode signal is Vc, which is represented by V1 plus V2 divided by 2. This is the average of the two input signal voltage, right? From the output, what we get? From the output we get A1 V1 plus A2 V2. What is A1? A1 is the voltage gain of the non-inverting terminal and A2 is the voltage gain of the inverting terminal. So voltage gain into input voltage plus voltage gain into input voltage. Total is equal to the output voltage we get here, right? That is V0 equal to A1 V1 plus A2 V2. From equation 1 and 2, what we get? That is V1 plus V2 equal to 2 Vc and V1 minus V2 equal to Vd. That means what is the value of V1? V1 equal to Vc plus half Vd and the value of V2 is Vc minus half Vd. If we equate this to equation V1 plus V2 equal to 2 Vc and V1 minus V2 equal to Vd, what we get? We get V1 equal to Vc plus half Vd and V2 equal to Vc minus half Vd. That means if this V1 and V2 value is substitute in this equation, what we get? We get the output voltage. So the output voltage V0 equal to half A1 minus A2 Vd plus A1 plus A2 Vc. If we substitute these two value in this equation, A1 V1 that means Vc plus half Vd, A1 into Vc plus half Vd plus A2 into Vc minus half Vd. So we get half A1 minus A2 Vd plus half A1 plus A2 Vc. Right? This half A1 minus A2 is represented as AD and A1 plus A2 is represented as AC. So the final equation is AdVd plus ACVc. So V0 equal to AdVd plus ACVc. Here we put that is A1 minus A2 divided by 2. That means half A1 minus A2 is equal to AD and A1 plus A2 is equal to AC. So what we get? We get V0 equal to AdVd plus ACVc. AD is the voltage gain for the difference signal and AC is the common mode signal gain. In the ideal case, AD is infinitely large while AC is 0. But in practical situation, this is not true ideally. And so here we get the common mode rejection ratio, that is the ratio of difference signal gain and the common mode signal gain, which is called the common mode rejection ratio, CMRR. Since AD needs to be large and AC is very small, that means the amplifier must be so designed that the CMRR is much larger than unity. I repeat, that is, since AD, that means difference signal gain, needs to be large and common mode signal gain is very small, that means AC is very small, the amplifier must be so designed that common mode rejection ratio is much larger than unity. Okay, so this is the condition of common mode rejection ratio of the operational amplifier. And this common mode rejection ratio is a significant feature of a differential connection, is that the signals are opposite at the inputs are highly amplified, whereas that are common to the two inputs are only slightly amplified. The overall operation being to amplify the different signal while rejecting the common signal at the two inputs. Okay. Since noise means any unwanted input signal. Noise is generally common to both inputs. That means the differential connection tends to provide attenuation of this unwanted input while providing an amplified output of the different signal applied to the inputs. This operating feature is referred to as common mode rejection. Okay. So this is the fundamental topic of an op-amp, that is what is common mode operation and what is the common mode rejection ratio, and this is very important topic of an op-amp. Hope you understand this topic. Thank you. Thank you. If you like, do like, share and subscribe my channel.